Welcome, polar bears and polar cubs. Let's do some intro to chemical reactions / we're going to do some counting atoms within a molecule and counting molecules as well. So as we get going, let's go ahead and get through some slides. So the main idea that we're going to talk about is chemical reactions and how they can be represented in chemical equations, how we can balance those chemical equations to show the number of atoms of each element on each side. And when we do that balancing, we need to keep in mind the law of conservation of mass. So what that says is that you cannot create or destroy atoms, so you have to have the same number on the product side as you did on the reactant side. So chemical reactions, they're everywhere. We have cooking, whenever you're going to go eat, respiration, okay, when we're getting energy, hair dye, auto fuel. You have color change. So how do we know that things happen? You have color change. You have something called a precipitate form. A precipitate is a solid that forms and then will eventually drop to the bottom within a chemical reaction. Usually happens when two solutions are added together. You have gas forming, okay, bubbles, or you smell an odor. Yeah, it could be bad, it could be good. Other things that would tell you is a change in temperature. So if you see temperature going up, it would be an endothermic reaction. If you saw it going down, if it was going up, it'd be an exothermic. That's right. Exothermic means it's producing heat. Endothermic, meaning the temperature going down, would be that it's absorbing it. You have a change in acidity. So we have pH, little pieces of strip, like a strip of paper that you put in there, and it would test the pH. So how do we observe it? So we observe chemical reactions, okay, and we came up with a model. So making NaCl, table salt, what happens is you supply, solid sodium, and then you have chlorine gas. You surround it with chlorine gas. It combines and it makes a table salt. Okay, you need to put coefficients in order to balance the elements. So right now you have, like, if without the coefficients, you have 1 Na, 2 Cls, and on the other side you have 1 Na and 1 Cl. So you have to balance it all. That 2 gets distributed to both elements. Within chemical equations, we're going to use these different symbols. A plus means that you're taking one product plus another product, or a reactant plus another reactant. It's meaning that it makes both. The arrow tells you that, hey, this side is the reactants, this side is the products. And then you may see some of these states. That's just telling you in what form you would find it. So a S means a solid. AQ means aqueous, meaning that's dissolved. It's going to look like a liquid, but it's in water, which makes it aqueous, aquatic, inside of water. And then you have L for liquid and G for gaseous. Gaseous. All right, so here's an example. You have methane. Methane is a gas. Okay, so you might put a G here. Oxygen's a gas. It produces some kind of heat. It makes carbon dioxide, which is a gas, and water, when it has heat, is a gas as well. If you count up your atoms, you have, on this side, you have 1 plus 4 plus 2, which gives you 7. On the other side, you got 1 plus 2 plus 3 plus another 1 for oxygen. So a grand total of 6. They don't equal. So we're going to have to eventually balance them. So I'm going to give you a nice little rundown on how to balance chemical equations. And we'll go over this again when we work on it in our classes. So you have 4 H's. That's going to make 2 waters then. 1C, 1 that. 1C, 1C, 4 H's. Now you have 4 H's on the right-hand side. You have a grand total of 4 O's. Well, you have only 2 O's on the left-hand side, which means you need to put a 2 here to balance it. And now you have the same number of atoms. Let's move on to the next slide. And the next slide shows you that you can have kind of make it into a algebraic equation where you have 3x plus 2y equals this. You can still do that where reactant A plus reactant B equals the product. Where reactants are on the left-hand side, products are on the right-hand side, and then the arrow shows you when we make that change. So the big part is when we get into our intro to chemical reactions worksheet, you want to be able to count atoms. So in order to count atoms, for example, with this one that's right here, okay, that 3 gets distributed to each atom that's in there. So you're going to take the coefficient tells you how many are there originally. So originally you have 2K. Well, you have 3 of them, 3 2Ks. So you actually have 6 Ks within that compound, or at least on that side. Same can be true with carbon. Originally you have 1 carbon. You're going to multiply by 3, giving you 3 carbon. Oxygen, there's already 3 O's, but you have 3 of those compounds, so you got to multiply by 3, giving you 9 oxygen atoms total. Now, when it comes to molecules, counting molecules is a little bit on the same route, except for the coefficient tells you how many of the molecule you have. So again, that 4 tells you that you have 4 Na2SO4 molecules. And then when you wanted to count the atoms, that 4 would get distributed and multiplied by the coefficient would get distributed and multiplied by the subscript. So for example, the 4 times 2 would give you sodium, so you have 8. 4 times 1 giving you 4 sulfurs, and 4 times 4 giving you 16 oxygens. And that's it for the intro to chemical reactions. You're going to go ahead and start working on that worksheet. And if you have any questions, let us know. Hey, don't forget to hit like or subscribe.